A very good morning, students. In this video, we will look at how the logical addresses get translated into physical addresses in a memory management unit inside a computer system and how operating system helps in performing this action. So, the general execution cycle is that you create a program code. So, for example, you create a .c file. Then when you compile it, the .obj file gets generated, which is the object file which contains the machine code. And then linking will happen, which will convert the obj file into an executable or a DLL library. Executable is one in which all the function calls have been linked with their appropriate function definitions, and DLLs are dynamically linked libraries in which the linking operation is performed when the library is actually loaded into the memory. And then we have the loading, in which the executable is brought into the memory as a process and actual execution will begin. So we have the first state compilation, second state linking, and the third state as loading. Now let us discuss how the machine codes are generated and how the logical address gets generated in this process. So suppose you have this small fragment of C code in which you have void main, you define 3 variables and then you sum these 2 variables and store the result in the third variable. The corresponding machine code that will be generated, I have written in assembly language. I have not used machine instructions. So in assembly language, the variable, it is assigned some position. So in my case, as you can see here, the first variable A, it has a value of 10. So I have written the address here 11100, which is this address. At this place in the memory, the value of 10 is stored. Similarly, for B, we have the address 1000 followed by 2 zeros, which is this address, and here we have this variable stored. Similarly, for the variable C, there is a memory section which has been marked and the address of that memory is stored here. So that this variable is linked to that memory location and the value is present at this memory location. When this code will be loaded into the memory, this particular variable A will have its value 10 stored at a offset or a logical address of this number. Similarly, each instruction is assigned a logical address. This is the LDA which says load the variable A into the AC register, then add B to the AC register, then store the result in the C variable. So this is how this program gets converted into the machine code or the assembly code. And look at the addresses over here. The first address is a decimal 4, then 8, then it is 12, then 16, then it is 20, then 24. So we can see that each of the addresses is separated by 4 bytes because generally one word of the memory is 4 bytes long, and therefore each of these values is going to take up 4 bytes in the memory when it is getting converted into the actual zeros and ones. So these logical addresses, these are calculated by the compiler. And then how these are connected with the physical address, let us look at that. Then we have the linking. Linking is to link the function call to a function definition. We put the logical addresses of the defined function in the place of the call using the subroutine call. What it means is, suppose I have defined this main function and I am calling a add function to add A and B and store the result into C, and this add function is defined separately. Then similarly, I am going to compile this code and the machine code or the assembly code will get generated. And here you can see the addresses. This is 0, this is 4, then 8, then 4, then 8, and then this is 16, then this is 20. This way it is all separated by 4 bytes. And then we have the main is stored at the first position. Here the variable a is defined at this memory location, which is this, and here the value 10 is stored. Then b is defined with the value of 10, c is defined with the value of 0 as we have initialized in the code. Then we say load the contents and add, make a call to add AB. Now what is this add AB? This instruction needs to be linked to this definition of add AB. So this subroutine linking is done by the linker, and before that it is a question mark, but after this particular linking will be performed, the address of the add AB will be put in this position and call this positions or go to this position. This code will be written over here so that the value can be fetched and brought into the AC register. So this way the linking is done in which the function call is mapped to the function definition by using the logical address of that function definition. Then let us look at the loading. In loading, the PCB of the program is created and suppose the size is 100 bytes. Now the base address is going to be the position where the PCB will be given space in the memory. So suppose it is 256, that is 2 raised to the power of 8. This is the binary address which is getting generated. So it is 7 zeros followed by a 1 because it is 2 raised to the power of 8. And then the limit is, this limit has to be a power of 2 because though the program size is only 100 bytes, but we will allocate in the powers of 2. So we allocate 2 raised to the power of 7, that is 128 bytes to this particular program, and this is the binary number for the limit. It is 1, 2, 3, 4, 5, 6, 7 zeros followed by 1, and here it was 8 zeros followed by 1. So that way the binary address is calculated for the limit. Now the last address will be 256 plus 128, that is 384. Adding this value into this, generating this binary number. Now loading of instructions at the base plus logical address. Now let us look at how the code will get space in the memory. So the base address is this, limit is this. Now what we will do is base plus the logical address is the position where this instruction will get loaded. So what we will do is in this digit we are going to add this first address, and that will be the location of the first instruction. Then this number 4 is added into this sequence, and that will be the location of the second instruction. Then this will be added into this base address, that will be the third instruction. This way the complete program is loaded into the memory. These are the logical addresses, and the physical address is calculated by adding the logical address into the base address. And as we can look at this diagram from the book Galvin, the computer generates the logical address, which is this address, and then we compare this address with the limit register. The address has to be less than the value of the limit register, and if it is less, then we add this value, we sum this value into the base register's value to generate the physical address. I hope this video is helpful to you, and if you like my video, please subscribe to my channel and share it with your friends. Thank you very much.